I'm going to try a slightly different setup and see how this works. When we start talking about memory, it's really nice to be able to see it on a whiteboard drawing. So let's see what we can do here. What we've been doing is static memory allocation, and that's when we just declare a variable. Maybe we have int a, we could assign it or not assign it. And that goes and puts the memory on our stack. So this area is called our stack. And when it's declared, it finds that spot, gives it the nickname A. It's not the pointer A. I don't have an arrow to represent that it's a pointer. It's just the variable A is labeled at this address, and we can put a 2 in there. If we want a pointer to A, we need a star to say it's a pointer, and then I name it pointer to A if I want, and then I can assign that the address of A with the ampersand. Now pointer to A is also some chunk of memory, and that's pointing to here, and this chunk of memory is actually on the stack too. It's just hard to represent it on the stack, and memory isn't all in one line anyway, so all this memory is on the stack. Let's look at what happens when we declare a class. We created a class named temperature. And so when we create an instance of it, it's going to call the constructor, and the constructor is going to grab some space to hold today's temp on the stack. What's actually being held in the temp? I think we stored a Celsius value. Or something close to that. If there had been another data member in there, then that would also be stored there. So when we go to today's temp and find the Celsius value, it's going to be here. And if there was any other data, that would also be stored on the stack. We could create another temperature. And that would grab another set of data to store another instance of our temp, and each instance has its own copy of the Celsius value and anything else that we might have with the class. So the compiler can pretty much figure out all the memory that's needed because it's all declared right here in your program. We've declared an integer, so it knows it needs to save a spot for an integer. We've declared a pointer to an integer, so it knows it needs to save a spot for that pointer to the integer. We've declared 2 different instances of temperature, so it knows it needs to store that. And so all that is saved on the stack, and that's what we've been doing so far. So what we're going to do now is introduce a new topic called dynamic memory.